Well, we've got some construction work going on outside, so hopefully a lot of that doesn't get picked up in this video here. But today we're going to talk about simplifying square roots, and we've already done this to an extent, just kind of in a different way. We've done something like, well, to simplify the square root of 36, that's 6. That comes out whole. 6 times 6 is 36. We've also done where we've simplified the square root of 40 by coming up with kind of an estimate of what it would be. And the square root of 40 is between the square root of 36, which is 6, and the square root of 49, which is 7. So we would say the square root of 40 is somewhere between the whole numbers 6 and 7. We're going to take this even a step further, and we're going to simplify these square roots so we can take out as much as we can of a whole number and just be left with a square root that we can't really simplify anymore. And I'm going to show you what that means. So the square root of 12 is obviously not a perfect square. The square root of 12 would be between the square root of 9 and the square root of 16. So our answer should be between 3 and 4, whatever we get. So what I'm going to do to start to simplify this is I want to think about the factors of 12. So factors of 12 would be maybe 4 and 3 would be a good choice. So the square root of 12 is the same as the square root of 4 times the square root of 3. So now I want to look at these options pretty closely that I have here. I can't do anything with the square root of 3. That's not a perfect square, but the square root of 4 is. So I'm going to rewrite this 2 times the square root of 3. And that's all I can do because the only thing I have left here underneath this radical sign is a prime number, so I couldn't do any 2 factors again because I'd just end up with 3 and 1. So my final answer to this problem is going to be 2 times the square root of 3, and this is how you'll see it written, with the number right up against the radical sign, meaning it's 2 times the square root of 3. Now, you can do this a lot of different ways because maybe you didn't come up with 4 times 3 as your factor. So I want to show you what I mean by this. So if I put this back on here, let's say we started out with the 2 factors of, how about 6 times 2? Okay? So neither of these we can do perfect squares for. So I'm just going to take another step further. I can't do any more factors for this because, well, I can, but it's a prime number. You could just give 2 times 1. So down here I'm going to do another set of factors, and I'm going to say, well, that would be the square root of 3 times the square root of 2. So here I've got all prime numbers now. But what we can do is the square root of 2 times the square root of 2 is the square root of 4. So now I've got the square root of 3 times the square root of 4. And now this ends up being just like what we had over here, where the square root of 4 is 2, so it's 2 times the square root of 3. So no matter what factors you come up with, you can break these down a little bit further, and you'll still end up with the same answer. So that's one example. Now, from any point on in this video, what I would do is if you think you have a good idea of what you're doing, give it a try and then watch through and see if you got it correct. Otherwise, just keep watching, go through the example, see if you can pick up what we're doing here, because the problems are going to change slightly. It won't just be starting with square root of 12. It might be something like 3 times the square root of 12 or something like that to start with, and we can still simplify those down. So I'll go to my next example here. So I've got the square root of 42. Okay. So square root of 42. I can do square root 7 times square root 6. Okay. I can't simplify any of those. I don't have any perfect squares. So I'll do square root of 7 because that's a prime number times square root of 3 times square root of 2. Now here's an example where all I've got is prime numbers here. And I can't multiply any of these together to get something that would get me a perfect square. Like remember in the last one we had the square root of 2 times the square root of 2, which was the square root of 4. Then we could simplify that. If I multiply these together I get 21. These together would be 14. These together would be 6. In none of those cases am I going to get a perfect square. So if you end up with something like this, that just means that that was the most simplified that it could possibly be. And I can show you another example of how I could do this and still get the same thing. Let's say for 42 I do square root of 21 times square root of 2. None of those are perfect squares. So I have to break these down. prime number here, so that's going to stay just how it is. And then this would be the square root of 7 times the square root of 3. We end up with the same thing here. I can't multiply any combinations of these together to get a perfect square, so my final answer is just going to be square root 42. That's as simple as it can get. Next example. Now we've got a couple different things here. We've got 3 as a whole number times the square root of 18, but I want to simplify this down more. So let me rewrite this. 3 times this right here. What could be two factors I could use for this? Okay, I'm going to do 9 and 2. So 3 times the square root of 9 times the square root of 2. So let's see if I can get any perfect squares out here. Okay, I've got 3 times, well, 9 would be, square root of 9 would be 3 times the square root of 2. That's a prime number. We can't branch it off any since it's a prime number. So we're just left with this. So now this is my final answer for the question, but I can do 3 times 3 and actually get 9. So my final answer is 9 times the square root of 2. That's as simple as we can go. Now, let's say you didn't pick 9 times 2 to start with. So now let me do 3 times, how about the square root of 6 times the square root of 3. This equals 18 right here. This equals the square root of 18. I don't have any perfect squares. This is a prime number, so I'm not going to be able to do anything with that. So let's work on this one. So now I'm going to rewrite this 3 times the square root of 3 times the square root of 2. This right here is my square root of 6 right there. And then I still have this times the square root of 3. Now, if you think about this a little bit here, I can multiply these together. And I'm going to end up with 3 times the square root of 9 times the square root of 2. Now I can simplify what parts of this? Well, this is a prime number, so it's just going to have to stay the same, and it's not a perfect square. This I can work with. So 3 times the square root of 9 is 3 times the square root of 2. So my final answer is going to be 3 times 3 is 9 times the square root of 2, which we couldn't do anything with. Now I've got 5 times the square root of 48. My problem's going to look like 5 times, and then I need 2 factors that make 48. Let's see, 48, a good one would be, how about 6 times 8? Okay. Now, neither of these are perfect squares, but both of them I can branch off. Both of them I can branch off, so I can actually make new fractions, which eventually maybe we can get some perfect squares. So let's try this. 5 times, so 6 can be square root 3 times square root 2. And then 8 can be square root 4 times square root 2. Okay, so let's see what we got here. I can rewrite this now as 5 times square root 3 times square root 2 times that right there can just be changed to 2 times square root 2. Okay, so now if I multiply the 5 times 2 together, I'm going to get 10. So I've got 10 times the square root of 3 times the square root of 2 times the square root of 2. Now, we could say that this is simplified, but it's not quite simplified yet. Because if I multiply this square root 2 times square root 2, I get square root 4. So it's going to be like this. 10 times square root 3 times square root 4. So now, I mean, using your knowledge of perfect squares, 4 is a perfect square. Square root of 4 is 2. So now I'm going to write 10 times square root 3 times square root 4, which is 2. 10 times 2 is 20, square root 3. That would be your final answer. We can't do anything with this right here, so that should be your final answer. We could multiply these together to get a perfect square number, so we did. Now again, there's a lot of ways you can do this. Maybe you don't start off with 5 times square root 6 times square root 8, because there are other factors that we could use for 48. So let me just give you kind of a quick picture of what I mean here. If I did 5 times 48 is 16 times 3. So 5 times square root of 16 times square root 3. 16 times 3 is 48. So now I can do square root 16. So now I have 5 times 4 times square root 3. Now I end up with the same thing that I eventually had down at the bottom here. 5 times 4 is 20 20 square root 3. So the key is, if you can find a number right away in the factors that is a perfect square, like the first time I did it, neither of these are perfect squares. The second time I did it, one of these is a perfect square. If you can find one of those perfect squares right away, it makes your process a lot simpler. And now you might not always be able to do that, but just know that either way, you'll eventually come up with the same conclusion. You'll come up with the same thing. A lot of ways to do this because 150 has a bunch of factors. So again, I'm going to do 6 times. Can I think of something right away that's a factor of 150 that's going to have a perfect square? And I can, because I know that 25 goes into 150. 25 goes 150 6 times. So now this problem is going to be pretty simple here. I can change this to 5 because the square root of 25 is 5. So it's 6 times 5 times square root of 6. So now I can just do 30 square root 6. And if I were to break down this square root 6 and get 30 times square root 3 times square root 2, there's nothing I'd be able to do with this because that's not a perfect square. That's not a perfect square. And I can't factor this any other way. So this is going to be my final answer right here. And understand, we could have done this a different way. It just would have taken longer. So if I would have done 6 times, let's see, to get 150, you can also do 50 times 3. So I could do square root of 50 times square root of 3. Let's see here. This can't be broken down, but this can. So I could do 6 times square root 25 times square root 2. That makes square root 50 times square root 3. Then this is a perfect square, so I could do 6 times 5 times square root 2 times square root 3. These I cannot do anything with, so my final answer is going to be 30 times the square root of 2 times 3 would be 6. That's as far as you can go with it. Last example I'll show you. Now, this is kind of an interesting one, I think, just to kind of prove some things here, but you know this is going to be 6. That's going to be your final answer. But let me just show you how you could use the process to come up with 6 like we just did. So square root of 36, let's say we do square root 9 times square root 4, let's say. Well, obviously if we did square root of 9 times square root of 4, we're going to get square root of 9 is 3 times the square root of 4 is 2, which is 6. Let's say I did factors of 36 being, well, let's do 6 times 6. We can break this down more. Square root of 3 times square root of 2 times square root of 3 times square root of 2. And then if we multiply the 2 and the 2 together, we get this. If we multiply the 3 and the 3 together, we get this. So we get back to where we started at. So even if you have a perfect square, you can still use this method to come up with your simplifying square roots. And again, if you still have more questions after this, once you've gotten done with this, there will be more practice opportunities after this, but please just make sure that you'll let me know.